Hi, Mr. T here with the fifth video on organic chemistry, looking at the naming and how we might identify some different groups of molecules or functional groups. Okay, so the first group we're going to look at in this video are esters. Esters always have this double bond group here to the oxygen, the carbonyl group, and also is bonded to another oxygen here. And on the other side of the oxygen, it's bonded to another carbon. Okay, so it looks similar to a carboxylic acid but it will look, a carboxylic acid group, but it will look completely different because there will be a group of carbons off there, an alkyl chain. So often when we write it in shorthand, we just call it COOO. And if we look at a molecule here, this is an example. The functional group is actually in the middle here. See the C double bond O. And the O attached here. When we name this molecule, it has two parts to its name. It has this blue part, which is the alcohol group. So this is like a methyl, an ethyl, a propyl, a butyl. And then it has the red side here, and this is called the anoate. So how we name this is our functional group. It's going to be something methyl, something anoate. So in this case, there are 1, 2. So this is ethyl, 1, 2, 3 on the OH side, ethyl propanoate. Ethyl propanoate. Let's have a look at another one. So this one here, we split it down the middle. Okay, we split it down the middle where the oxygen is. I put a line through there, and then I look at the side that is just a carbonyl chain. It's just carbons and hydrogens. Now this is going to be the aryl part, so this is going to be called propanol. And then we have the side with the double bond O, and that's the anoate. So it's methanoate propanol. And that's how we name esters. Okay, let's look at acyl chlorides or acid chlorides. They look again like a carboxylic acid because they're a derivative from a carboxylic acid, but they have a C double bond O with a chlorine attached to it. These are very highly reactive substances. So they contain the COCl functional group. Now we name these by we replace the E with an oil chloride. So let's have a look. Here's an example. This has 2 carbons, so we take away from ethane the E and we call it ethane oil chloride. Ethanoyl chloride. Ethanol chloride is its name. Here's another example. We name it exactly the same way. Functional groups on this side. We don't have to put a number because it's always off the first carbon. So this is butanoyl chloride. Okay, last group we're going to look at in this video are amides. Amides again have the C double bond O, but the group off the end here is an amine group. Or this amino group, sorry, it's not an amine, this is an amide because it's got a double bond oxygen, but it has this amino group here. Now, we can classify these as primary, secondary, or tertiary. Now, we do it in the same way we classified amines. That is, a primary is when we just have and primary amide is when we have 2 hydrogens coming off and 1 bond to the oxygen. A secondary is when we have another acyl group. Here it's a methyl group attached to the nitrogen. So the nitrogen is attached to an oxygen and a carbon. This is a secondary amide. This one is a tertiary amide. It has 2 groups of carbons and hydrogens plus the oxygen. So we have a primary, secondary, and tertiary. And it's all dependent on how many bonds to the nitrogen that aren't hydrogen. They are named in the same way as the others, we take the E off the end and we put amide on the end. So this one here would be called propanamide. Propanamide. So you say it as one without a gap, propanamide. This one here, 1, 2, 3, 4, butanamide. And that's how we name amides. Now, of these 3, there are 2 that we can do distinguishing tests for. The amides, not so much. They're not really a base that's strong enough to give us a blue solution when we put a red litmus paper in. So they really have a negative reaction to everything. But if I want to identify esters, esters are really common in nature. They have a sweet or fruity smell. They don't dissolve in water, so they'll float on the top of water like a wee patch of oil. With acyl chlorides, it's very easy to determine them because they're so reactive. If you drop them in water, they will act violently with water. They'll fizz if you put a drop of it in water because it's very reactive. So we add it to water and it produces actually hydrochloric acid. What happens is the chlorine is replaced by an OH here, and the chlorine and the other H get together. So when we add water to an acyl chloride, we get a carboxylic acid. Obviously, this is going to be a base, so we can drop it in the water, and then we get a base produced. An acid produced, and the acid will turn blue litmus paper red. So we can test for that. And the other thing we can do is we can test the gas evolved because it's hydrochloric acid, but usually the gas coming off is what we can do is we can have a damp piece of blue litmus paper and we can test the gas coming off and see if it goes a red color, it's hydrochloric acid.